So good morning, students. Today we would like to proceed from the portion where we have left in the previous class. Uh, what we need to do is we first start with the important terminologies of ANN. So this is one artificial neural network. What we need to do is that we are now reached at a point where we are going to deal with certain models where ANN is involved. So before going to that particular involvement, what we need to do is we first want to learn what are the important terminologies what we are going to experience in our today's class, and not only today's class but also in the next one or two more classes which are related with the ANN. Now first important terminology is going to be weights. Now if you can remember the previous class as well, so basically what we learned is that these x1 x2 up to xn, all these are input data, right? So these can form input vectors as well. So basically all this input data is connected with the next node by with some kind of weights associated with the connecting links. So basically this is called weight, and this w1 w2 up to wn, all these are considered as weight, and all together can form a weight matrix. So basically these weight matrix are the directed communication link which basically exists from one neuron to the next neurons, or to the neurons which you know uh, which lie in the next level or next layer, you can see. So each communication link is associated with weights, what I have just told, and obviously this weights carries the information about the input signal. Why? Because every time whenever if you can recapitulate the previous class, if I go to compute this y, I mean, you just not you just forget about this bias and this all these things, all this terminology, and just let us take an example that we have only this one particular neuron, which is the new input node is getting abbreviated as x1. We are having one weight, that is w1, and automatically we are having one again one neuron which is in the next layer or next stage, and we are having one output like y. So if you can remember that this y is getting obtained due to x1 into w1, so automatically this weight carries information about the x1, and that is why we are going to consider the product term of this x1 and w1. And obviously that if we have more than one input vectors, I mean more than one input data as well, so basically this y is going to be computed as a summation of this xi and wi, where I is nothing but the 1 to n. So now this weight matrix, whatever be the matrix, this is being formed by taking all the weight values. So this weight matrix is also called the connection matrix. So this is the first terminology, which is weight. Now coming to the bias. Now what is bias? You can see that there is one input as here shown, that is b, that is termed as b. So this bias is nothing but it is calculated, it usually calculates the net input. Net input means that suppose we are having this kind of input vectors like x1, x2, x3, and up to xn, and automatically we are having this weight as well associated with all the input vectors. So those are the w1, w2, w3 up to wn. Now what happens that sometimes it may happen that need some kind of bias adjustment. And this bias adjustment is, it is nothing but, if you can consider that this is this particular connecting link, that if you consider that this particular connecting link is also having some kind of weight, which is absolutely correct, that weight is obviously that weight would be would be denoted here as w0. So what is that w0? That w0 is every time that is 1. So basically what happens, that whenever we are going to compute that what is b into that w0, as we always compute that x1 into w1 or x2 into w2, so here basically the input is b, like x1 x2 or xn. And obviously this weight, the values of weight is every time that is equal to 1. So automatically what we need to find is, we always get the only b. So that is why here, if you see at this particular point, that this is the calculated net input, this is the calculated net input, that is y in, that is why it is written in this manner, that is it is only b, because w0 is 1, plus obviously there is a summation which we usually follow for computing the output in case of artificial neural network, that is summation I equal to 1 to n xi wi, and obviously this I is nothing but this number which is associated with the x and w vectors. Now, so in that term what input vector looks like, because in the previous slide, till the previous slide, when the bias has not been introduced, we know that the input vector is like x1 x2 x3 and up to xn. That is what we usually tell. But here what happens, that mm, we are getting a kind of input vectors which is 1, which is for this w0, and we are having um, that uh, kind of input vector here right now, 1, that is x1, that is x2, and obviously that will go on up to xn. Okay, I have already, unlocked this entry. So whoever wanted to join, they can join. Okay. So now this is what your bias is all about. Now coming to the next important terminology, which is called threshold. Now, what is threshold? Threshold, if you can look here, that you have some kind of, value over here. So basically, what is threshold? Threshold is, obviously we are going to, whenever we are going to form the network, so basically the final output of the network, what we are very much bothered about. So basically final output of the network may be calculated based on this threshold. So this threshold is applied inside the activation function, which already we have covered in the previous class, like step function, like ramp function, like signum function. So basically what happens here, that whenever you have this kind of network, so network output is obtained to compare between the calculated net input, what we have seen in the previous slide, and obviously the set threshold value. That means automatically we have certain kind of threshold value where we want to reach, where we want to reach. So what happens, that there is a constant comparison between these two values, that what we want to reach and what we have obtained as a calculated net input. And obviously there is a kind of comparison, and there is there always lies a kind of the strategy or the action which is going to be taken place in case of ANN, where we fall fall apart from these threshold value, as we have obtained as in the form of calculated net value. So what now the question is, and that is going to be, discussed in the later slides. Now in this particular slide, what we are going to, highlight that if, so now if an activation function has a threshold value, then how can we, calculate the output of this particular network? So that then the output network is going to be calculated as either one, if the net value is, net value means the calculated net input value obviously is greater than or equal to that threshold value, and it will return, I mean it will, I will consider, or you will consider the output value of the output of the network as -1 if the calculated input value is less than this particular theta. So we have only this binary option that either we are getting, we have to, take, or we have to consider +1 or -1 based on the threshold value. So that is why in the first line, it has been written that final output of this network may be calculated based on the threshold value. So this is the, the thing which is basically uh, all about the threshold. So now the last important terminology of ANN is the learning rate. And whenever you are going to, uh, follow the all the weight updation rule which are associated weight updation rules, I must say, because that weight updation rule is associated with multi-layer feed forward network, then it is associated with backpropagation neural network. So all these weight updation rules, whenever you are going to follow, you will find that there are a kind of, terminology which says learning rate. So what does this learning rate means? This learning rate determines the rate of learning at each time step. So basically it controls, what amount of, weight adjustment we are going to, consider at each step of training. That means even, I mean, that means it may be happen that we can have, a large difference between the calculated net input and the threshold. That means automatically what we have here as the desired value, and what we have here as the opt-in value or the actual value. So we can have, a large discrepancy between these two values. But this learning rate determines that what amount of, change you can allow for, adjustment of this weight at each step. You cannot, if you can have a, a very big difference between these two, you cannot jump into one step, I mean, to, avoid this particular, differences, or, to make your actual output value as the desired value. So you can jump, but automatically whether you can jump or whether you can not jump, that depends on the, the rate of learning which already, is going to be assigned in your problem. So that is why it is called the learning rate. I mean, the rate at which the artificial neural network also learns to, to adapt a kind of, changes in which manner the weight is going to be adjusted at each stage of training, obviously. Now, the value, coming to the value of this learning rate, it ranges from 0 to 1, and it is all, usually it is denoted as alpha, or, a small value of a, small letter of a. So these are all important terminologies which are associated with ANN. Whenever you are going to find the further slides for this particular topic, you will find anywhere all these terminologies. So now, whenever we are already, associated with all the terminologies, now we are going to familiar what are the different phases of artificial neural network. So usually it has two phases. One is training phase, another is testing phase. So usually what happens that in the training phase, this artificial neural network, finds all the weights which are associated with the inputs, so that it can represent the relationship between the inputs and the outputs. And in the testing, and obviously in the training phase as well, what I have just told you that in that particular case, so basically what happened that in that manner, so basically what happens that in the training phase as well, the weight updation or weight adaptation techniques are also, going to happen. Now, in the testing phase, when this is used to correct the model output, this is called the testing phase. The testing phase means whenever the training algorithm has been automatically, set. That means the training algorithm or training phase is, over. Then what happens? The testing phase begins. So in the testing phase, what happens that now the artificial neural network is ready to, to find the correct output, and obviously that correct output is the model output what we desire. So these are two phases of artificial neural network, which we are going to, highlight in the next slides. Now, what are the what is the, standard structure of artificial neural networks? That means what are the different, layers, we can say, what are the different, formations, we can say. We can, look, if any of us, look at the artificial neural network architecture. So automatically in the previous class as well, I have seen two diagrams of the single layer feed-forward network and multi-layer feed-forward network. So automatically from that very slides, you have already, learned that these are three, different structure, different units, which we can see whenever we are going to have any artificial neural network. So automatically it will have an input unit, it will have an hidden unit, and automatically it will have an output unit as well. So we know that that these input units are going to be represented as a fixed length vector or numbers which are user defined, and this is called hidden units, which I have just told that automatically here the weight updation process is going on, and it is basically representing all the calculations of the network, which inside the, inside the network, what are all the calculations which are taken place to, update the weights, and automatically it will reflect the relationship between the input set and the output set. And obviously this output units at the last, it also represents a fixed length vector or of numbers, basically, which is a single, output vector, which is only, reflecting you the output result or the model output. Now, before going to the next slide, I would like to request you to, give all your attendance. And by the time this particular session is going to be closed, I will again, online through the next session within 2 to 5 minutes. Now, coming to the neuron connection architectures, what are the, the most important part of this ANN? That first one is single layer feed forward network. The second one is multi-layer feed forward network. Third one is single node with its own feedback. Fourth one is single layer recurrent network. And obviously the fifth one is multi-layer recurrent network. So coming to one by one, what we have here is we have single layer feed forward network, and you know that this particular slide you have seen in the previous class. Okay, can we all see the screen?
Ma'am.
Okay.
Yes, ma'am.
Okay, so what we have here is that is the single layer, feed forward neural network. So what we have, that you can see in the previous class as well, that this is a particular slide. What we have already saw that this is the input layer of the source nodes. What we have in the left hand side of this particular model, we have here some kind of output layers of the neurons, which basically gives you the output um, vector, as you say, and or you can see, or you can say that the output result as well. So basically what we have here, that is, this is a kind of graphical representation of the single layer feed forward network, and where we all know that the nodes are going to represent the neurons. The arrows obviously represent the signal flow direction. These all these things we know about it. And one spatial form, we know that this is a kind of spatial perceptron. Yes, Shonali, tell me. Okay, so this is one spatial form, which is being called as the simple perceptron, right? Simple perceptron. Now, what is this? This is basically what happened, that here, what is different from what we will have in the next. Uh, okay, Shornal is facing network problem, so screen is not visible to her. Uh, is the screen is I mean the visible for all of us, I mean the remaining.
Yes.
Okay, so what we have here, that this is a simple perceptron what we have here. So in the on the contrary, what we have in the multi-layer feed-forward networks, what we have seen in the previous class, that this is a kind of multi-layer feed-forward. Why it is called multi-layer feed-forward? Because on the contrary to what we had in the previous network, that is the single-layer feed-forward network, basically we had some input node and we have some output nodes, but here obviously we can experience some kind of hidden layers as well. That means more than one, I mean either one or more than one hidden layers we may expect in case of multi-layer feed forward networks. And here you have to understand then why it is called feed forward network, because we don't have here any feedback loops. So automatically any kind of loop or any kind of cycle that we don't see in this kind of feed forward neural network. So that is why we have here this kind of layering as well, which is known as the hidden layers. And you can understand that whenever we are talking about artificial neural network, and in the previous slide, I mean in the first class of the artificial neural network, can you remember that I have compared this particular neural network is just like whatever we have the neuronal modeling inside our brain. Why we have called this? Because all this inputs, all these inputs are the external stimuli, right? All these outputs are what we are going to you know uh, provide to again the external environment. All these are happening in the hidden layers, that is basically happening inside our brain. That is what you can see over here, that this is what the output layer is all about. This is what we have, the input layer. And this is the all the neuronal modelings basically is inside our brain, which are the hidden layers, because we have a number of 1,000 or billions of neurons inside our brain, and all the neurons are connected in this manner, so that very much computation, very much complex computational task as well we can perform so easily, because we have certain hidden layers inside our brain. So basically this is what no, artificial neural network is all about, and it has a similarity of our own neuronal structure. Now, coming to this particular slide where we can focus or highlight about the points where these multi-layered networks are different from the simple perceptrons or the single layer, feed-forward networks. What we can see for multi-layered networks is it has one or more layers of hidden units. We can see from the previous slides, but here, we cannot have any hidden layer. We can only have some hidden unit, right? But we cannot have some kind of hidden layers. And that is why it is called simple perceptron. Obviously, with two possibly very large hidden layers, it is possible to implement any function because we have large hidden layers, so we can compute certain, very complex computational task as well. But here, on the contrary, these perceptrons are very limited, what they can represent, because it cannot, deal with multi-class classification. It is very much, confined with two-class classification, and also the simple one. But obviously, whenever it is limited with the simple problem, so automatically its learning problem is also getting, much simpler than what we have in case of multi-layer networks.